Hi guys, welcome to the next lesson on organic compounds, alkanes. In this lesson, we're going to be talking about alkanes and what they mean, as well as how they're drawn using their structural formulas and condensed formulas, as well as Lewis diagrams. I'm going to be also talking about how to name these molecules using the IUPAC systemic nomenclature. It's just a fancy word for how to name molecules according to a system that chemists use. So hydrocarbons. Hydrocarbons, they're known as organic molecules and they contain a carbon and hydrogen atom. There's three types of those atoms. We're going to be studying one type today. So the three types are alkanes, alkenes, and alkynes. Alkanes is spelt with an A-N-E at the end, alkenes E-N-E, and alkynes Y-N-E. So alkanes, which is what we're going to be talking about today, are a saturated hydrocarbon, which means all their carbons are surrounded by a hydrogen atom or a carbon atom. So there's no double bonds in alkanes. For example, here we know that carbon has 4 valence electrons. With those 4 valence electrons, all will be bonding to other atoms. So over here we've got 1 carbon atom bonded to 1 hydrogen, 1 other hydrogen, 3 hydrogens, and 4 hydrogens. Over here as well, we have a carbon, which is bonded to 1, 2, 3 hydrogens, and another carbon. So total 4 valence electrons are being used to bond. Therefore, there are no double bonds, only single bonds in alkanes. Alkanes, already mentioned, have only single bonds between them. To name alkanes, you use the prefix over here in this table, meth being for 1 carbon, eth being for 2 carbons, prop being for 3 carbons, but for 4, and etc., all the way up to dec. So the prefix is going to be one of those compounds names there. The suffix is going to be ANE for alkanes, because they have one carbon bonded to a maximum number of others. So, for example, all bonds are made single in alkanes. So they're all saturated. So in this case here, we've got 1 carbon atom, as you can see 1, therefore it's given the prefix meth. So the suffix is ane, because it's a hydrocarbon of an alkane variety. Therefore we put the two together, methane or methane. If you look at the second one here, second molecule, we've got 2 carbons bonded to maximum number of hydrogens or other carbons, so it's saturated, therefore it's eth and ane, ethane. In order to name or look at if a compound is an alkane, we use this formula where we have N being the number of carbons, so here is 1, and number of hydrogens in an alkane will be 2N, so 2 times the number of carbons plus 2. So for example, we've got 1 carbon, we multiply the number of carbons by 2, which is going to be 2 in this case, and we plus 2, that is going to be the total number of hydrogens present in that alkane. Again, for ethene, you can see that there's going to be 6 hydrogens present. Now we're going to be looking at 3 terms that are going to be important for naming and drawing hydrocarbons, specifically alkanes in this lesson. So the molecular formula, we've already talked about, that's the exact ratio of elements. The structural formula is the physical structure, showing all bonds, which is over here, and how they are arranged in space. And the semi-structural formula is a semi-structural or a structural representation of the atoms and how they're organized, but it doesn't show their bonds. So for example, the molecule ethane over here, because we have 2 carbon atoms bonded to the maximum number of hydrogen atoms, ethane is shown as CH3, CH3. If you were to group these 3 hydrogens and this carbon into a formula like this, that would be a semi-structural formula. So what I want you to do now is I want you to draw the different structural formulas of these following alkanes, and then I want you to draw structural formulae and name the following. When you've done that, move to the next part of the lesson. So you should pause it now, draw these compounds in your book, and then move forward. Okay, so the next component we're going to be talking about is alkyl groups. So on a hydrocarbon or an alkane, we can have these side chains, and these side chains are named as such. So if you have a side chain, we have, for example, we have 4 carbons here, and this one has a little side chain. That side chain, if it's a 1 carbon atom, it's known as a methyl. If it's a 2 carbon atom, it's known as an ethyl, which is shown here. And if it's a 3, it'll be a propyl, etc., etc. This will be important for what we're going to do next. So if we're naming an alkane, sometimes we have more than just a straight chain hydrocarbon. So what we need to do is we need to identify the longest carbon chain in that atom. So for example, over here, we have a total of the longest chain being 1, 2, 3, 4, 5, 6. So we have 6 carbon atoms as the longest chain. We do have, obviously, 7 carbon atoms, but the longest continuous chain of atoms has only 6 carbon atoms in it. So we've identified the longest unbranched carbon chain. Then we need to number all the carbon atoms, so we give the lowest number to any alkyl group. So if I had numbered the carbon chains the other way, 1 here, 2 here, 3 there, 4 there, 5 there, and 6, this alkyl group over here would have the number 4 written at it, or the fourth position. That's too high a number, so we don't want to number it in that direction. We want to number it in the other direction, where the alkyl group, or the CH3, has the lowest number on the carbon. So we've done that, as you can see in this diagram here. So now I know it's a 6-chain carbon atom, or hydrocarbon rather, so it's going to be a hexane. And I know that on the third group, there's an alkyl group, or third carbon, there's an alkyl group called a methyl group. So I'm going to have identified that from the previous table. So I've got a methyl group on the third hydrocarbon, and I've got a total chain of 6. Therefore, I've got 3-methyl hexane. These steps 5 and 6 will become relevant for later. So what I want you to do now is we're going to go through one more of the naming alkanes, and then you're going to have a go at naming your own. So again, we identify the longest carbon chain. If we were to number from this side, 1, 2, 3, 4, 5, we've found the longest continuous chain. However, we have given a higher number to the methyl group over here. So instead, we name it from right to left and give the methyl group the lower number, or 2. We've got 5 carbon atoms, therefore it's going to be a pentane if they're all going to have the maximum number of hydrogens, and they've got a methyl, so it's going to be 2-methyl pentane, and we followed those steps to do so. Now what you to do is to draw structural formulae of the following 2 molecules, and then draw structural formula and name the following alkanes. Once you've completed that, move on to this component here. So alkanes, they can also have halogens. These halogens are known as group 7 elements, which are fluorine, bromine, chlorine, and iodine. We can have these molecules or atoms attached to hydrocarbons, and we give them the prefix as such, like this. So if we have a bromine atom attached to an alkane, we find the number of carbons in that alkane, and we know it's 3 in this case, so therefore it's going to be the prefix prop. And we know that it has at position 1 in the atom, so we've numbered it with the lowest numbers to the alkyl group, which is the bromine in this case. In position 1, we have a bromine atom. So we call it 1-bromo and then prop, because it's got 3 carbons. It's saturated with a maximum number of hydrogens or other bonds, so no double bonds. So it's going to be 3-bromopropane. Same over here, 1-bromopropane on the first carbon. Over here, we've got the same. We've got on the first carbon atom, we have a bromine atom, so it's 1-bromopropane. In the case of this one here, we've also got a propane molecule because we have 3 carbons. However, the chlorine is on the second position no matter which way you go. If you were to number it 1, 2, 3 or 1, 2, 3, it would still be in the second position, so we give it 2-chloropropane. So extended or more developed way of writing structural formulae with halogens is when you have 2 or more of these fluorine, bromine or chlorine or iodine atoms. So if you do have more than 1 of these atoms, we use prefixes like di, tri, and tetra. So for example, let's look at this in context. Here we've got a propane molecule because we have 1, 2, 3 carbon atoms, and on the first and second carbon atom we have 2 chlorines. So we know it's going to be propane. It's an alkane. It's got 3 carbons in it. We know there's chloro groups, so there's going to be a chloro in front of the propane, and we know that there's 2 chloros, so it's a dichloro. And we also give the position number, which is 1, 2. In the case of bromine here, we find the longest carbon chain, 1, 2, 3, 4, and you also have to give the lowest number to the alkyl groups, so this is the correct numbering. We know it's going to therefore be butane. It's going to have bromines in position 1 and 2, and there's 2 of them, so it's 1,2-dibromobutane. So using that information, I want you to name the following compounds, and I want you to then draw these 2 here. So summary of today's lesson: alkanes are made of hydrocarbons, which consist of only single bonds, and they're so-called saturated. They have named in a specific order, which was generated from that table we saw, and alkyl groups refer to an addition of a side chain. Halogens are just adding a bromo, iodo, fluoro, or chlorine to the atom. You should be able to identify alkanes' chemical structure, name a hydrocarbon as an alkane using the first prefixes, name them using the halogens or haloalkanes, and we'll go through balancing chemical reactions in the next video. These are the questions to complete. Thanks for watching.